If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture on gate measurement series. So today again we will be solving 5 questions starting from question number 106 up to question number 110. Okay, then let's try to solve these questions. Okay student, in question number 106, the probe of a non-sinusoidal 2-channel oscilloscope are connected to ABC points in the figure. Bin is the square wave of suitable low frequency. Display of channel 1, channel 2 is shown in the figure. The signal and ground connection of this channel 1, channel 2, S1, G1, S2, G2, how it is connected. Okay, so you can see this ground is connected here. That means one signal is increasing like this and one. So because it is connected across either a resistance L, resistance R, resistance L, that means it is giving voltage measurement, voltage waveform. So channel 1, you can see it starts from 0 and keeps on increasing, and this is start from a negative voltage and then finally it comes to 0. So it is an inductor. So you can think of an step voltage giving to an inductor. So inductor is an RL circuit, standard RL circuit. So starting inductor will be open circuit and gradually it will be short circuit at the end. So what will happen? So and R is continuously, as from the starting it will be 0, then as the inductor is gradually getting shorted, so this current will keeps on increasing, and so that your resistance voltage across this is also increasing. So the resistance voltage, that will be always positive. So if I mark it, this is plus, because there is no negative half, so plus minus. So this voltage will be plus minus, and this voltage, if I consider this is plus minus, so if you see this one now AB, so it should be, so one probe should be at here, one probe should be at B, then this voltage will come, because it will start from 0. As current is increasing gradually, the voltage will keeps on increasing and it will be at particular limit it will reach. And your inductor voltage at the beginning, it will be negative. It is not like that, the drops will be, finally it will be 0. At the initial value, this drop will be negative. So you can see this will be then CB now. So it should be connected to CB, it should be connected to AB. So at the beginning it is negative of this one, what you have considered. Then it will reach to 0. Finally it will reach to 0. So this is our load convention. We generally take plus minus in this direction because my current is moving in this direction, so we always take this correction. But this initial will be negative and finally it will reach to 0. So you can also think it in this way. So initially this voltage and this voltage should be same. So if there is voltage, same voltage is developed, then no current will flow. So that's why the voltage will be exactly same voltage. Whatever voltage you give, that will be same voltage. That means VBC will be equal to same. But because it is showing negative, so that means you have to connect it in reverse direction. That is, you have connected CB. So that is your option B, you can see. So 106, it is option B. So by seeing the waveform only we can do, without doing writing any equations or something else. This is resistance starting from 0. This is inductance starting from a equal value of voltage, but you have connected reverse, that's why it is, and finally it will reach to 0. Now 107, two sinusoidal signals P and Q are applied to the XY inputs of a dual channel, this one. The pattern, Lissajau pattern, is displayed in the signal. Now the signal this can be represented at. Now if you draw this horizontal and vertical line, so now maximum number of vertical cut you can have 4, maximum number of horizontal cut you can have 2. So the ratio is 2:1. That means your fx by fy, so it is 107. The frequency at x-axis divided by frequency as y-axis is tangent. Sometimes it can be also seen as tangent also, intersecting. You can find it intersecting, or you can do it with drawing a tangent also, horizontal and vertical tangent. But finding tangent may be difficult, so this intersecting point is easy. So y is 4 it is, and x is 2, so this is 2. So whatever you connect in y, that means in x-axis you connected this one, omega 1. So y-axis you should connect it, so your fy should be equal to fx by 2. So y should be equal to by 2. That means y1 is, that is y, w2 should be half of w1. So that means it should be either B and D. That is okay. That is for sure. So A and C will not be. So let us see now B. B is exactly same. B, if it is exactly same, only there is a change in frequency, but there is no phase shift. So if there is no phase shift, this type of circles doesn't form. This is actually circle. So if this type of circle has to be formed, then there has to be angle difference of 90, either lagging or leading. That we have seen. So that's why it should be cos and sine, there is a 90 degree lagging, because sin 90 plus theta is your cos theta. So that's why it is option D. B is not there because it is option D. Why? Because it is giving a circle shape. That means there is a phase difference between these two. This one we have seen. So in question number 108, two 8-bit ADC. One is single slope integrating, one other is successive approximation. One is SAR, one is dual slope, that they are considering only single slope integrating type, not the integration part. Take TA TB times to convert 5 volt analog input to equivalent digital output. If the input signal is reduced to 2.5, the time taken. So this one we have explained, both dual slope and successive as SARs. I will give a link, you can check that out. So what was there in SAR? What was there in integrating? Dual slope, it was something like this. Single slope integrating, then didn't. So here it is only a single slope. So if it's integrate, if you voltage limit is, you are less, if it is a 5 volt, it will keep on integrating up to the entire signal. So if it is a 2.5 volt, so it will stop at 2.5 volt. So your time will be reduced. If it is a single slope integrating time, then time will be reduced, because that depends on, you can find the time conversion formula also. Conversion time is, there is a T2 is equal to 1 plus, there was a formula 1 plus, for in case of dual slope there is a formula T2 is equal to 1 plus VA by RS. So that you can think of, like, because it is not dual slope, so something of that fashion, that will depend on input signal. So if you reduce it, that will also reduce by half. But you see, as SARS type, if you have seen as a successive approach, it starts from maximum MSB, keeps the MSB 100. Suppose it is a 4 bit, so it starts from 100. You check it converts its equivalent reference voltage, then it's check whether input is greater than or smaller than. If it is greater than, then it keeps it 1, then it's check from next. So it is bit by bit checking. First these will take all 4 bits, so it will start from MSB, then it will check for next bit, next bit, next bit. Every time it will be checking all 4 bits. So whatever voltage, if you reduce it to 2.5 also, it will start from this 100, then it will stop at whatever voltage you are giving. But it will check for each and every bit. So it will come from starting and it will complete the whole 4 bits. After, at the end of this, whatever, suppose you got 0011, so this is your answer. But it will start from checking from 100, highest MSB, keeping MSB 1. So its time is always fixed. So it depends on number of bits converted, not number of input voltage. So therefore it will be same. So it is TB. That means your option B. Now if you come to 109, the average reading of a digital multimeter reads 10 volt when it is fitted in triangular wave, symmetrical about time axis. The same input of RMS value will be giving. So if its average is giving, it is symmetrical about x-axis, so something of this fashion, triangular wave. So if I say average, suppose this is T, this is T by 2. So this position is T by 4. Okay. So if it is average, then total average, if you take average for full cycle, it is always 0. So that means it is giving for this type of signal. I told you, if it is required to find average when it is symmetrical about axis, we take only half portion. Now we take average of only one half. So if you take average of this one, what is the average? This is a triangle. So average means integration then divided by total. Integration is nothing but area. So this area you can find it without doing integration also. Half height is here. What is the height? So what is the height? Suppose this is my height x. So x into base. What is the base? T by 4 divided by total is T by 4. This is the average value. What is the answer? They have given 10 volt. So if you solve it, you will find your x is equal to 20. So now, once you know x equal to 20, now you can find this RMS value also. So for RMS, you need to integrate it from here to here. But if you can integrate up to this, then it will be same, because if you square it, so negative will also be positive. So if I take only this portion 1 by 4, because rest are symmetric, the way it is increasing, same way it is decreasing. So this, each triangle, this triangle, this triangle, this triangle, all are same. So if you square it also, everything will be same. So that's why I am doing only this one. This height is 20, this is T, suppose. So what will be its RMS value? So it will be under root. What is the average? Average, if you will take for up to this much, 1 by 4, and then you integrate it 0 to T by 4 summation, and then square. So what is the equation of this one? This is y equal to mx line. Y is your voltage, suppose V. So V is equal to mx. M is the slope. Slope is this by this. This height divided by this height. So this is 20 divided by T by 4. It was y equal to mx of this format. Y equal to mx. Y is here V, x is here time. So V is equal to, and m is here slope, this by this. Height by tan theta, slope is this by this, height by this. So if we apply this one, so it is 20 by T by 4, then it's whole square into T t square, that is dt. So I think you can do it. It is 4 by t. This integration will also come out 4 square by t square 20 square, and then t square is t cube by 4, so it will be t cube by 4 cube. So t square, t cube, 4 cube, everything will be gone. So you will get it, there will be t cube by 3 in the integration. So you will find it is 20 by root 3. So this is your answer, that is option A. Now if you come to 110, two inputs of a CR was fed with two stationary periodic signals x and in xy mode. This screen shows the figure which is changing from ellipse to circle, then back to ellipse, which major axis is continuously changing orientation slowly but repeatedly. The following interference can be made by this. That means initially, suppose if it is this circle, then next is this ellipse, next is again the ellipse is changing, next is again this circle, again this ellipse, so it is continuously changing. So what do you can refer by seeing this? How this figure changes, this pattern? The pattern changes when the angle between them changes. Angle should not be constant. If it is a constant 90 degree, then it is circle. If it is a somewhere between 90 to 270, then it again this type of. So if it is a 270, again it will back. If it is a between 180, so you find all these angles. This is another one. So all these 4 cases you know, we have explained this one. So this depends on particular phi. If your phi is fixed, the figure will fix, it will not move. That means your phi is continuously changing, your angle. So the signals are not sinusoidal, it is not the correct one. Both the signals are sinusoidal. Amplitudes are very close, not equal. It doesn't depend on amplitude. These signals are non-sinusoidal with their frequencies very close, not equal. Now frequency is very close, not equal. So if their frequencies are different, then there will be continuous change, because the way it is changing, one phasor is rotating, the another one is not rotating in the same frequency. So it will be continuously changing. If you continuously measure, it will be better if I draw it in vector diagram. Suppose this one is rotating at 200 speed and this is rotating at 198 speed, another phasor. So what will happen? The angle between them will keeps on changing between them. It will not be same. Initially if it is 30 degree, and after some time the one which is speed is more, so it will go move fast, it will be move slow. So the angle will increase. So once they complete again they will, because by the time it reach here, it will complete one cycle, it will again come, though it will again be 0. So again if it starts from 0, it keeps on increasing 360 degree, finally again it's meet, because one is very speed, it is moving at higher speed than another one. So what will move faster and it will cross it before it cross it, at a time it will again meet, again it will start crossing it. Had it been linear, suppose two persons are moving in a circular track, so what will happen? The person who has a move faster, it will be continuously covering the distance with a very less time, and it will every time it will cover the same person after some time. First so two persons, first they will meet somewhere here, again they will meet somewhere here, because by the time second person come here, the first person will take one rotation. So they will continuously meeting at these different points, so the angle between them keeps on changing. Had it been in straight line race, then if one person cross another one, then after that he moves away. He never sees this person again, because it is straight line, he is not coming back. But here every time he is coming back, so he will see one more time. He will see that person one more time, the person who are at slower speed. So that means the angle will keep on changing. So the answer is option C. So the frequencies of them are very close, but they are not equal. Because it is very close, that's why it is very slow change. So you can slowly and repeatedly, they are saying. Repeatedly means it will repeat because it is continuously moving in circular direction. There is a constant phase difference. Constant will not be occurring, because if there is a constant, then figure should have been a constant. If you like the video, then press the like button and please give your valuable comments in the comment section.